Soccer ball.
Can we make it a bowling ball?
We can make it whatever you want. Soccer ball gets kicked. Okay? The velocity here is how much?
23 meters per second. At an angle of 40.
It says 27.
Oh, 27. 27. Okay.
What? Oh, I'm on number 7. My bad.
Okay, yeah. So 27 meters per second. Now, you know that this ball will do what?
Backflip.
Okay, what's the normal path that things take?
Parabola.
Yeah, it's a parabola, an arc, right? So it goes up, it goes up, and it comes back down. Parabolic path, right? So it's going to go up and then fall back down. Cool? That's our picture. No, we don't have to do that. I'll show you. All right, so this here is theta. Theta is my angle. As far as your givens that you start out with, guys, the givens are velocity is equal to 27 meters per second, and theta is equal to 40 degrees. Those are your givens you start out with. Now, what you're going to want to do is you're going to want to split this paper into an x dimension and a y dimension.
Where do we write this?
I'm putting your bowling ball.
So split your piece of paper. Thank you, sir. And the reason why we do this is because the ball doesn't act the same. It doesn't follow the same rules in the x and y dimension. In the x dimension, we don't accelerate. In the y dimension, what is there? Starts with a G. Gravity. Brings everything down. So in the y dimension, things are going to happen, right? This ball will accelerate in the y dimension. It's not going to accelerate in the x. So, somewhere on your piece of paper, you need to write your equations. So I'm going to move it over to the next slide real quick. Somewhere on this piece of paper, you need to write these equations. Velocity in the x direction, guys, will be equal to velocity cosine theta.
Will you write this?
Okay?
Can I grab one for Will?
Yeah. You just write it somewhere off to the side, guys, wherever you have space. Velocity in the y dimension will be equal to velocity sine of theta. Okay? So this is your, this comes from SOHCAHTOA. Remember we did SOHCAHTOA? Sine is opposite over hypotenuse. Okay? Yeah. So we're going to do that. Now, for the y dimension, you also have this. You should know that, what is it? Acceleration is going to be equal to v final minus v initial all over time. That's one equation. This is all in the y dimension. Yeah, you do. Well, for the most part. In the y dimension, this is what's happening. You also know that v final squared is equal to v initial squared plus 2a delta y. And delta y is equal to vi times t plus 1/2 a t squared. For this equation, if your initial velocity in the y direction is equal to 0, then time will be equal to the square root of 2 delta y over a. Those are your equations.
These are all for Y.
Yep, right where it says Y dimension,
Yeah.
see how it's all under that?
So, in the x dimension, guys, all I basically have is velocity in the x is equal to v cosine theta. And you also need to have velocity in the x is equal to displacement in the x over time. Here's our problem. We only know two things. All we know is velocity is equal to 27 and theta is equal to 40.
Yep.
So what we're going to have to do is find out the rest. In the x dimension, I know that the velocity in the x is going to be equal to v cosine of theta, right? And so velocity in the x will be equal to, what's v? 27, and then cosine of theta, which is 4. So I can get velocity in the x as,
Oh, it's so
Huh.
cute.
So you already have the velocity given to you.
you have velocity given to you, but it's only given to you
Oh
in
my
the
gosh, that's your pencil. I wasn't even aiming for it.
in the x and the y. See, it's given to you at an angle. So you can't use this velocity at an angle. You need to split it up into its x and y components. Okay?
And I saw Carrie.
And so the reason why we need to split this up, guys, is because
Just kidding.
our velocity in the x dimension, guys, this velocity here,
Oh yeah. I know.
it stays constant, okay? If I take this eraser and I decide to throw it, okay? If I throw it at, let's say, 30 miles per hour, it should hit the wall. Oh. My bad. That hit you? Okay, cool. I forgot they bounce. Okay. Hit the wall at 30 miles per hour. Does that make sense? That velocity in the x direction stays constant. The velocity that's changing is in my y dimension. In my y dimension, this ball, or this eraser, if I toss it up, it goes up, right? But it slows down as it goes up. At the very top, what's its velocity? 0. See, it stops for a split second. So it slows down, stops, and then it speeds back up, coming down. Cool? So that's why we need to split it up into the x and into the y, so that we can figure out this one doesn't change, that one does change. Cool? So our velocity in the x dimension, guys, we're going to pull out our calculator. If you have a graphing calculator, first thing that you have to do is hit mode and make sure it's in degrees. Right now it's in radians, okay? If we try and solve this using radians, it's going to be bad. So you got to switch it over to degrees, and then we can go back. So I hit 27 cosine of 40. I close the parentheses. Oops, that's 0. 4, 0. Close the parentheses, enter, and I get 20.68. So our velocity in the x dimension is 20.68 meters per second. Now we can go over to the y dimension. Okay? In the y dimension, velocity in the y will be equal to velocity sine theta. And so velocity in the y is equal to 27 sine of 40, which is equal to how much? So, it's up.
Okay. He knows everything about
Good sleep then. 27 sine 40. All right. So there you go, 17.36. 17.36 meters per second. Now, in the x dimension, do we have acceleration? No. This question is asking how long will the ball be in the air? Okay? So, if it's asking how long the ball is going to be in the air, in the x dimension, velocity in the x dimension is equal to displacement over time. But I don't have displacement in the x dimension, right? And I don't have time, so I can't figure this out. So we're going to go over to the y dimension. In the y dimension, I know this. This is my initial velocity, right? That's initial velocity. What's the final velocity going to be in the y dimension? When this thing reaches the top, our velocity is how much? 0.
That's initial.
Okay? So what we're going to do, guys, is this. We're going to split this up to half of the problem. We're going to split it up to just half. Because at the top here, I know that velocity is how much? V is equal to 0 at the top. Now, the amount of time that it takes to go up is equal to the amount of time that it takes to go back down. So once you figure out what your time is to go up, what do? Multiply by 2. Pretty simple, right? What do I know about acceleration in the y dimension? Negative 9.8 meters per second squared. And I know that I'm looking for what? Time. So, I have time, A, VF, and VI. Yoder, which equation do I use?
Arnold.
Yoder, which equation do I use? I have A, VF, VI, and T.
Yeah, you know, which equation?
What she said?
Yeah.
Okay. Which was?
Are you just putting my gun?
Okay. A, VF, VI, and T, right? So this is the only one that matches, so that's the one I'm going to use. So I know this. I know acceleration. By the way, guys, here's your givens. Okay? Here's your unknown. So there's that section. Now we're writing out our equation. Our equation is A is equal to VF minus VI over T. I'm looking for time, so I'm going to switch these two variables. Time is going to be equal to VF minus VI over A. Okay? Cool. And now I actually have to plug stuff in.
Was that for the initial velocity at the top of the y? Where does it Vy?
Correct. This is initial velocity.
So you just simplify.
Yeah, I put an I here, but it's not very.
So they're I.
Yeah, there's an I. So it's VIY. It's initial velocity. Nope. Yeah. Okay, to rearrange it, guys, you're going to multiply by time, right? And so you get A times T is equal to VF minus VI. And then to get the T by itself, you divide by A. See, like this. You have A T is equal to VF minus VI. Because you multiplied by time, right? And so now you know that you need to divide by A to get T by itself. Cool? Yeah.
They're so fast, it's not even.
All right. So we're going to find time. Okay, time is equal to VF is how much? Okay, so 0 minus 17.36 divided by negative 9.8. And you see these are two negatives, right? This 0 goes away. So a negative over a negative is equal to a positive. So I take out my calculator. I use this number, and I'm going to divide it by 9.8.
Negative.
The negatives canceled out. See, it's a negative over a negative, so those canceled out. Yep. So I get 1.77. So time is equal to 1.77 seconds. But that's only the time to go up, right? So like he just said, you've got to multiply it by 2 to get the total time. Okay? Because that's the time to go up. That's the time that it takes to reach the top. I need the time that it takes to go up and down. Huh? Yes. It's a lot.
Yeah.
And so times 2 gives me 3.54. So times 2 is equal to 3.54 seconds. Yay!
Yeah.
That's all we're doing today, right?
Huh?
Can we do another
No, we're
one?
doing
Wait,
two
why'd you
more.
times it by 2
That's
again?
really confusing.
What?
Why'd you times it by 2 again?
Because that's the time that it takes to go up and down.
Wait, does that say x2 equals?
What? Times 2. Times 2. So I multiplied it by 2 because I found the time that it took to go up, right? Because I found the time that it took to get to b is equal to 0. Then I multiplied by 2 to get total.
3.54?
Hmm?
3.54?
Yep. There's another equation that we could have used, but I'm not sure if I want to. Yeah. Yeah, what the hell, why not? Let's try it. So, one other equation, guys. You see this equation here, where delta y is equal to VIT plus 1/2 AT squared? If this object starts off at the table, and then it lands on the table, then what's its displacement? We did this before. If you start at home and you come back home, what's your displacement? 0, right? You're running around the track. You start on the starting line, you end on the starting line, right? 0. So if displacement is equal to 0, then this equation would become this. 0 is equal to VI times T plus 1/2 AT squared. What you can do is, you guys know about factoring out T's? Factoring out variables? Some of you do. That's why we don't do this generally here, but that's fine. There's a T in both of these, right? There's a T in both of these. So if I divide by T, okay, then this T goes away, and the square goes away. It's only leaving you with one T. Okay? Well, when you divide this side by T, what's 0 divided by T?
0.
0. So I get 0 is equal to VI plus 1/2 AT. Okay? So, if I solve for time, all right, then what you're going to do is subtract VI, right? And then multiply by 2 and divide by A. So you end up with T is equal to, this is another equation that we can use, guys. So T is equal to negative 2 VI over A. If I were to write that down over here, where's that last page? If I wanted to use that over here, where time would have been equal to negative 2 VI over A, then time would have been equal to how much? Well, I can multiply here. Hopefully it'll come out to the right amount. So 2 times my VI was 17.36. And I divide that by 9.8. 3.54. Yay, it works. And that's amazing. Okay? I know. I wasn't sure that was actually going to work out, by the way. It's like, let's try it. Math.
I was trying to do one more.
So, 2 different ways that you can solve it, guys. This one's a little bit longer because it involves you actually multiplying by 2, and a lot of people forget to do that. This one is true if delta y is equal to 0. Okay? If delta y is equal to 0, so it starts off and it ends in the same place, then you can use that equation. And here time was equal to 3.54. Okay? Lots of fun. Number 2.
So excited.
Oh, yeah. A soccer ball is kicked. from the ground with a velocity of 31 meters per second at an angle of 37 degrees above the horizontal. Find the distance that the ball travels before it hits the ground. So, we're done with this, yes? You guys take pictures, do whatever you need to do?
I wrote it down.
Just wrote it down?
Yeah.
Okay, good. Alright. Oh yeah, pictures are amazing, man. That's why you guys have phones, right?
Yeah.
That's why I have a phone. Take tons of pictures.
Are we doing the same?
So different things.
Same thing, solving for something different. Last time we were solving for time. This time we're solving for how far the ball travels, which is delta x.
I
So,
don't even remember. It's so old.
Uh,
Tribal part.
good question. So this is 31 meters per second, and this is an angle of 37 degrees. Okay? I know that V is equal to 31, and I know theta is equal to 37. So x and y dimension, here's my x, and here's my y. Okay, in the x, I know delta x is what I'm looking for. So that's my unknown. How do I know that? Because it says a soccer ball is kicked from the ground with a velocity of 31 meters per second and an angle of 37 degrees above the horizontal. Find the distance that the ball travels before it hits the ground. Okay? So it does want distance before it hits the ground.
So if it asks for
Yeah, so
distance,
delta
it's
x.
always on the x.
Huh?
So if it's asking for distance, we're always.
Yeah, well, if it's asking for height or distance up, then that is delta y. Okay? How far does it fall? That's delta y. If it's asking for how far it travels, then that's delta x. Okay? So, I know that the velocity in the x direction will be equal to v cosine theta. Or velocity in the x direction is equal to 31 cosine of 37. So velocity in the x direction is equal to 31 cosine 37. 24.56. 24.56. Velocity is measured in meters per second.
What formula are we using to solve this?
For distance, good question. So the formula in the x dimension, if you remember here, we wrote down that velocity in the x is equal to displacement over time. And so that's the formula that we're going to be using. So in the x dimension, we know that the velocity in the x is equal to displacement over time. If I need delta x, then delta x will be equal to velocity in the x times time. But I don't have time. Okay? So if you don't have time, you need to go over to the y dimension to find that time. In the y dimension, I know a couple of things. I know that the velocity in the y dimension is going to be equal to, initial velocity in the y dimension is going to be equal to v sine theta. So initial velocity in the y dimension is equal to 31 sine 37. Therefore, the initial velocity in the y dimension is equal to, and pop this up. There we go. And so 31 sine 37. And I get 18.66. 18.66 meters per second. Other things that you know in the y dimension. This object, this soccer ball, it's kicked from the ground, it falls back down to the ground. So what's delta y? Yeah. Delta y is equal to 0. So it starts off and it ends in the same spot, right? Starts off on the ground, ends on the ground. is delta y is equal to 0. I know that acceleration is equal to a negative 9.8 meters per second squared. And I know that I'm looking for time.
Need to rearrange that formula.
Yeah. So your original formula is this one. Delta y is equal to vi times t plus 1/2 a t squared.
I was just gonna ask you, I have to take my English lesson before this isn't
No.
Is that
Yeah, that's fine. Okay. So that's your original equation. The rearranged equation, when we know that delta y is equal to 0, we wrote that down, right? If delta y is equal to 0, then I just wrote this, right? This is if delta y is equal to 0 meters. Then this is true. Then time is equal to negative 2vi over a. So time will be equal to negative 2vi over a. Good. So time is equal to, let's go ahead and use it. That's negative 2 times vi, which is 18.66. Okay? And then I divide that by a, which is how much? Negative 9.8. Okay? And I get 3.81.
I need to plug it into text.
So 3.81 seconds. And exactly like you just said, I'm going to plug it in over here. All right? So now I'm going to take my time, and time moves over here.
So then you multiply the 24.56 by 3.81?
Correct. So I get delta x will be equal to 24.56 times 3.81, and I get that delta x is equal to, good, 94.3.
Well, that's not right.
94.3 is what you got? Okay. All I did was not round, so that's the difference, but 94.3 meters works out. Same thing. Okay? So, one thing I want to mention, guys, all of your answers are down here on the bottom. Okay? These answers, sometimes you'll get something that's off by 1 or 2 decimal places. All right?
That's okay.
That's okay. I'm okay if it's off by 1 or 2 decimal places. What's not cool is if you somehow got like 104. You did something wrong. Okay?
Like 10.
If you get 93 or you get 95, yeah, you're off a little, but it was probably rounding somewhere, right?
Yeah.
So if you somehow get 0.2, definitely wrong. Okay? Don't do that. Have people do it. So, everybody understand what we did? Yes?
Yeah.
Okay, good. Third problem is actually really easy, really short. Where is it? There it is. Okay. For the third problem, if we draw it out, guys, we have a baseball that's falling off of a table horizontally. Here's my table. I know that the height of this table, delta y, is equal to how much? 0.7 meters. And I know that this baseball falls how far away? 0.25 meters. So that's what I know. It says how fast was the ball rolling when it left the desk? Oh, that's kind of mean. Yeah, we can do that. So here's what we know. If we split this up into our x and our y dimension, in our x dimension, we know delta x is equal to 0.25 meters. We know we're looking for velocity in the x dimension. Why do I know that I'm looking for velocity in the x? Okay, it's asking for initial velocity, right? And initial velocity is which way? Horizontal, in the x. Does that make sense? This ball rolls off a table. Does it start by going downward? No, it starts going sideways and then it falls down, right? Gravity makes it go down. But it starts off rolling completely horizontally. So, velocity in the x is what we're looking for. And I know that velocity in the x is equal to displacement over time. I need time. So in the y dimension, I know that delta y is equal to 0.7 meters. I know acceleration is equal to negative 9.8 meters per second squared. Since this object is falling down, what do we make this delta y?
Negative.
Negative. It starts here, it ends down. So we make delta y negative. What's our initial velocity in the y? 0 meters per second. And we're looking for time. The only equation that fits is delta y is equal to vi times t plus 1/2 a t squared.
Wait, what did you get for the initial velocity on the x? The motion.
Correct.
Wasn't there supposed to be an I between?
Oh, it's the same. Yeah.
Wait.
Because in the x dimension, guys, initial is equal to middle is equal to final. The velocity in the x dimension never changes. Okay? So whether it asks you for that velocity, the horizontal velocity to start with or to end with, or somewhere in the middle, the velocity in the x dimension is always constant. So time will be equal to the square root of 2 delta y over a, and time is equal to, bust out the calculator, 2 times negative 0.7, divide that by negative 9.8, and take the square root.
You okay?
I get 0.38, 0.38 seconds. I take that time and I plug it in over here. So, velocity in the x dimension is equal to 0.25 divided by 0.38. And so velocity in the x dimension is equal to 0.25 divided by 0.38, which is equal to 0.66. 0.66 meters per second. Done. All right, guys. Good job today. Amazing.
First time I've actually done them all.
Got them all?